No one saw this coming from Toyota. Not Wall Street analysts, not Detroit veterans, and definitely not the EV superfans who were convinced Toyota was years behind. But almost overnight, the world's biggest automaker stunned everyone with a breakthrough that could flip the entire EV race. Toyota has unveiled a solid-state battery built not for theory, not for lab tests, but for real-world cars. It promises ultra-long range, lightning-fast charging, and a huge jump in durability and efficiency. And this isn't some futuristic prototype sealed behind glass. Production has already begun on Toyota's pilot lines in Aichi, Japan. The first car to use it, a compact Toyota aimed directly at the global market with a surprisingly accessible price tag. Within days of the reveal, the entire industry scrambled. Automakers, suppliers, EV startups, everyone. Because this moment isn't just about range or charging speed. It marks a shift in who controls the next era of battery technology. For years, solid-state batteries were treated like distant sci-fi. Maybe by 2035 if we're lucky. Toyota just proved the future is landing much earlier than anyone thought. For decades, the EV world lived under the limits of lithium-ion. Powerful, yes, but restricted by range anxiety, slow charging, and the constant threat of overheating. Everyone knew lithium-ion wasn't the final form. The mystery was, who would break through first? And the shocking part is that Toyota, the company famous for slow, cautious, ultra-safe engineering, is now the one leading the next leap forward. There was no dramatic countdown, no massive live stream, no fireworks. Instead, the news came quietly from a private engineering summit in Toyota City. Behind closed doors, surrounded by executives, partners, and top engineers, Toyota confirmed what many thought was still impossible. Their solid-state program had advanced far enough to begin transitioning toward real-world production. These new cells have been through extensive testing for many months, integrated into prototype battery packs that set new performance benchmarks. The performance numbers are impressive, extremely long range on a single charge, and recharge times far faster than conventional EV batteries. In simple terms, it's the kind of progress that could reshape how electric vehicles are built and used. In a closed meeting, there was, this one slide that simply read, "Beyond lithium." That phrase really signaled Toyota's belief that we're on the brink of a whole new era in battery development. Solid-state cells are not only lighter and more durable, but they're also more stable under stress, and can store a lot more energy than traditional batteries of the same size. The upshot? We're talking about better range, improved handling, and a much more efficient use of energy. Another key improvement comes from, the way the solid-state pack itself is built. Since there's no liquid electrolyte, the battery is a lot more stable during collisions and does a better job managing heat. The energy density goes up a lot, which means more power without the extra weight. According to Toyota's own stress tests, these batteries offer a long life and hardly lose any capacity, even after years of heavy use. Plus, the cells stay cooler during fast charging, or when you're really pushing the car, which boosts both safety and performance. But, Toyota hasn't just focused on the battery. They're also working on a next-generation charging system that's designed for extremely fast energy transfer. This new technology uses advanced cooling to deliver very high charging power, which really cuts down on wait times. That said, such fast charging does need some extra infrastructure. So Toyota plans to pair each station with energy storage units that can safely handle the load and prevent any strain on local power grids. This setup lets vehicles charge quickly without overwhelming the electrical system. Safety has always been a priority in high-performance batteries, and Toyota has turned it into a major advantage. Their solid-state packs remain stable across extreme temperatures, from freezing cold to extremely hot environments, without swelling or leaking. Even in puncture tests and crash simulations, the batteries remain far more stable than traditional packs. In controlled testing, the heat spread and reaction levels were significantly lower compared to standard lithium-ion batteries. And Japan is only the beginning. The next major step is Toyota's new battery gigafactory in Thailand. Designed from day one for solid-state production only, no older lithium-ion machinery, no hybrid setups, a completely clean sheet approach for the next era of battery manufacturing. By 2026, that plant is expected to produce Toyota's first model built entirely around a ceramic solid-state architecture. Internally referred to as the Toyota X1, it represents a full ground-up shift. It's not just another electric SUV, it's the first Toyota engineered fully around solid-state capability. The targets are ambitious, exceptional real-world range, ultra-fast charging, and a starting price positioned for mass adoption. Instead of slow evolution, Toyota's aiming for a major leap forward, a design that could mark a significant shift away from traditional combustion vehicles. The X1 uses Toyota's new cell-to-frame integration approach, where the battery pack forms part of the vehicle's structural core. That means no wasted space, reduced weight, and improved rigidity. Early internal estimates suggest the platform could be significantly lighter than comparable models like the RAV4, while offering improved strength and safety. And since the vehicle is designed for large-scale production from the start, Toyota expects it to become one of their most important models. While Toyota advanced, much of the industry, paused. Many automakers that invested heavily in older lithium-ion technology now face some pretty tough choices. Factories optimized for older chemistries may require major updates. Partnerships and expansion plans are being reassessed as the market begins preparing for a shift toward next-generation battery systems. Battery manufacturers worldwide have reportedly begun exploring licensing Toyota's ceramic electrolyte technology, the same chemistry many once considered just too difficult to scale. Now, interest is growing quickly. The momentum is building beyond a single product. Industry observers note that Toyota's methodical, long-term investment in materials science, particularly in the development of a stable, manufacturable ceramic electrolyte, is what allowed this leap. While other companies race to scale existing lithium-ion production, Toyota's research division quietly worked on solving the fundamental challenges of solid-state technology, preventing dendrite formation, ensuring consistent ion conductivity, and creating a scalable manufacturing process. This breakthrough, therefore, is not an accident, but the result of a strategic choice to prioritize foundational innovation over immediate market share. This shift sends ripples across the global supply chain. The demand for key materials is predicted to change significantly. While the need for lithium remains, the reduced reliance on nickel and cobalt, coupled with the elimination of liquid electrolyte solvents and complex separator components, could streamline sourcing and reduce both cost and ethical concerns. Mining and refining companies are already adjusting their long-term forecasts, while chemical manufacturers are racing to develop the specialized precursors needed for ceramic electrolyte production. In just a few days after Toyota's announcement, the market reacted strongly. Companies focused on older battery chemistries saw reduced investor confidence, while next-generation technologies became the new focus. As one analyst said, "This isn't just competition anymore. It's consolidation." Toyota's leadership summarized their approach with one statement that spread through the industry. "We didn't just improve the car, we removed the compromise." And that message reflects their broader strategy. Charging becomes less of an issue when a vehicle can recharge in only a few minutes. Long-term durability improves when battery degradation is significantly reduced. Supply chains become simpler with chemistries that avoid several scarce materials. Toyota isn't just updating battery technology, they're reshaping the entire economic model behind electric mobility, and the X1 is only the beginning. By 2026, Toyota plans to expand solid-state applications far beyond cars into home energy storage, larger grid systems, and even experimental aerospace platforms. Imagine remote communities powered for days by stored renewable energy, or ships and aircraft operating with energy systems once thought impossible. Many of these concepts are already in testing stages. Toyota's decision to rethink their strategy years ahead of the industry has shifted the conversation. The auto world is no longer defined only by horsepower or design. It's defined by storage density, fast charging, and how vehicles integrate with energy grids. Whoever leads in battery technology shapes the future of mobility. Right now, Toyota has positioned itself at the front of that race. The era of traditional lithium-ion is beginning to evolve, and the solid-state era is starting to take shape. For Toyota, this isn't about following a trend, it's about setting the direction.